Welcome to Statistics. This is the Introduction to Statistics video, which means we're going to talk about some basic terms related to statistics and just kind of give you an outline of what statistics is, okay? All right, so let's get started. All right, what is statistics? Statistics is the science of collecting, organizing, summarizing, and analyzing information to draw conclusions or answer questions. It is about providing a measure of confidence in any conclusions. All right, that's the formal definition, but basically, statistics is basically you want to collect data to answer some type of question that you want to know. Okay, so you come up with a question and then you collect data and you see what information you get from that data, and then you can draw conclusions related to that question. And that's what we're going to learn how to do in this class. How do you collect the data? How do you organize the data? How do you summarize the data? And how do you draw those conclusions? Okay. So here's an example. A community college notices that an increasing number of full-time students are working while attending the school. So the administration, they randomly selected 128 students and asked the students how many hours per week they work. And the average number of hours the 128 students worked was 25 hours, okay? And so basically this is just an example of there's something that the school wanted to know. They wanted to know how many hours the students were working each week. And so they collected data. They collected data from 128 students and they figured out how many hours it was. And so there's a lot that can happen with that information that they collected, which is what we'll talk about in the future. All right, so here are some key terms that you will need to know that we will discuss throughout this entire course. First is data, okay? Data is the information that is collected. So the information that you collect, that's the data, okay? It's also described as a fact or proposition used to draw a conclusion or make a decision. All right, so this is what we use, the information that we collect, this is what we use to draw conclusions and make decisions. Information used to describe characteristics of an individual. So that's another way that data is described. It's information that we use to describe the characteristics of an individual or thing, because we may not be collecting data on an individual. And then data varies. So we have different types of data, which we're going to eventually discuss. And so you have a variation of data. So here's an example, that same example that I just discussed. The community college notices that an increasing number of full-time students are working while attending the school. The administration randomly selects 128 students and asks how many hours per week each works. And the average number of hours is 128. The average number of hours of the 128 students is 25 hours, okay? So now the data in this example is the amount of hours per week that each student works. So that's the information that was collected. The number of hours that each student reported that they work a week is our data, okay? So I wanted to highlight that here. Population. Population is the entire group of individuals to be studied. All right, so the population is who you want to study. So back to our example, a community college notices that an increasing number of full-time students are working while attending the school. So our population will be all full-time students at this community college, okay? All full-time students at this community college is the students that we want to study. That's the entire group of it, so that will be our population. Individual. This is pretty straightforward. It's exactly what it sounds like. That's a member or object of the population. In this example that we've been discussing, it's a member of the population of full-time students. So one full-time student would be considered an individual in our population. And that's what I just said. An individual is one full-time student. Sample. Okay. So now this is the issue. Populations can get really large. And so when they get really large, sometimes it's impossible to collect data from everyone in the population. So what we do is we just collect a subset of the population that we can collect from, and we call that the sample. Okay, so in this particular example, at the community college where they polled 128 students to see how much time does full-time students work per week, the 128 students that were polled is our sample, okay? So I don't know exactly how many full-time students there were at this school, but they only got information from 128 of them. So the sample will be the 128 students, okay? The population is all of the full-time students. So say it's 3,000 full-time students at this school. That would be the population, the 3,000 students. But the sample is actually the 128 students that they collected data from. Hopefully that makes sense. All right, and statistic. A statistic is a numerical summary based on a sample. So the information that we collect, the numerical information that we collect from the sample is our statistic. So in this example, the students reported on average that they worked 25 hours per week. So basically they took the hours that each student reported and they took the average of it. So to take the average of that, they would add up all of the hours and divide it by 128 because it's 128 students. And they got an average of 25 hours. So our statistic is the 25 hours, okay? That's the average of the number of hours that the students work per week. And that's the information we got from the sample. So that makes it our statistic. Now, inferential statistic, it uses methods that take results from a sample and extends them to the population and then measures the reliability of the results. Okay, so even though we only collected information from 128 students, there are some methods that we can use that we're going to learn throughout this course where that will allow us to take the information we got from the 128 students and make some generalizations and some predictions about the population, okay? And then with those methods, we usually get a measure of reliability of the results, okay? So we're going to talk more about that, but that's just basically saying there are methods that we can use that will allow us to take the information we get from the sample and extend it to the population. And then descriptive statistics, it consists of organizing and summarizing the data. So these are usually the tables and the charts and the graphs that you see to represent statistics. These are your descriptive statistics, okay? So this consists of organizing and summarizing the data, and we're going to talk about more about those too, but usually these are your averages, your medians, your mean, your mode, those types of statistics. Those are your descriptive statistics, okay? A parameter is a numerical summary of a population. So if for some reason we know the numerical value associated with the population, then we call that the parameter. So for example, if they were to ask all of the full-time students how many hours they work a week and then took the average of those hours, then the average number of hours will be the parameter. So if they were able to collect data from all of the full-time students and get an average, that average will be the parameter because it describes the whole population. So the difference is with a statistic, that's just the value that you get for the sample, and a parameter would be the actual value you get for the whole population. So here's an example. Determine whether the underlying value is a parameter or a statistic, okay? So remember, parameter deals with the whole population and statistic deals with the sample. All right. So the average score for a class of 30 students taking a final exam was 75%. So the value is the 75%. Is that a parameter or a statistic? What do you think? If you said parameter, then you are correct. So why is this the parameter? Well, this is a class of 30. So who are you studying or what are you studying? You're studying a class of 30. And that's all of the students. Assume there are no students absent. That's all of the students in the class. And their final exam average was a 75. And so since that represents the whole population, that would be a parameter. 13.5% of Americans aged 12 and over used drugs in the last month. Okay. 13.5% is our value that we're looking at, and we want to know, is that a parameter or a statistic? If you said statistic, then you are correct, okay? So why is this a statistic? Well, it says our population here would be Americans age 12 and over. Now, there is no way that they could sample every American age 12 and over. That would be a difficult task to do, to sample that full population. So this 13.5% has to represent a sample of that population. And because it represents a sample of that population, then 13.5% is a statistic and not a parameter. Hopefully that makes sense. So if your value represents the whole population, then it's a parameter. If it only represents the sample, then it is a statistic. All right. And the last thing we're going to talk about in this video is the process of statistics. So this is the process that you will go through to collect and organize everything that's associated with statistics. So the first thing you have to do is identify the research objective. So there's something that you want to study, there's some question that you have, and you have to identify what that is. The second thing that you'll do is you'll collect the data that you need to answer that question that comes from that research objective in step one. Once you collect the data, the third thing that you'll do is describe the data. And then the fourth thing that you do is you'll perform an inference. And that's basically taking the information that you collected from the sample and making an inference about the population, the full population from it, okay? So for example, Pew Research conducted a poll and asked, do you trust all or most of your neighbors? The researchers surveyed a sample of 1,628 adult Americans. Of those surveyed, 847 stated that they trust all or most of their neighbors. So first of all, notice that do you trust all or most of your neighbors? So there is no way that Pew Research could sample or collect information from every adult American. So what they had to do was select a sample. The sample is the 1,628 adult Americans who responded to their survey. The 847 is those out of that 1,628 who said they trust their neighbor. All right. So this is the process. The first thing that they had to do was identify the research objective. And what they wanted to know is, do Americans trust their neighbors? Okay. Do you trust your neighbor? All righty. So the population was adult Americans. Second, they had to collect the information needed to answer the question. There's no way they could sample everybody, so they had to take or collect information from the full population, so they had to take a sample, which was the 1,628 adult Americans. And they asked them, do they trust their neighbor? So then step three, they had to describe the data and organize and summarize the information. So of the 1,628 individuals in the survey, 847 of them stated that they trust their neighbors, all or most of their neighbors, okay? So they had to calculate the percentage of that. They took the 847 divided by 1,628 and multiplied it by 100. And this told them that 52% of the people surveyed trust their neighbors. So this is a descriptive statistic because it is a summary of the sample data, all right? So this isn't a parameter. It doesn't describe the full population. It only describes the sample. Alrighty. So then they have to draw conclusions from the data. So Pew Research wanted to extend the results of the survey to all adult Americans, and we'll figure out how to do that later, but this is just telling you what happened. So when generalizing results from a sample to a population, the results aren't certain, okay? And that's in anything you do. You can't just automatically say because 52% of the sample trust their neighbor that 52% of the whole population trust their neighbor. But again, there are methods that will allow you to make these generalizations. So what they did was, to account for the uncertainty, they reported a 2.5% margin of error. And that really comes out to be a 5% margin of error because it's 2.5% on the front end and 2.5% on the back end. If that don't make sense, don't worry about it. We'll get deeper into that later. All right. This means that Pew feels fairly certain that the percentage of all adult Americans who trust all and most of their neighbors is somewhere between 49.5%. That comes from subtracting 2.5% from the 52%, and 54.5%, and that comes from adding that 2.5% margin of error to the 52%. And again, we're going to talk about this later, so don't worry about the mathematics associated here. I just want you to understand that there's a range that they give, a range outside of this 52% that was calculated from the sample, okay? So this is the statistics process. This is what you have to go through again and I'll go back to that slide. This is what you have to go through the process of statistics, okay? So this is a very basic introduction video to statistics, and if you stay with me and you keep watching the videos, you'll learn a lot more related to statistics, and I'm looking forward to teaching you all. So if you have any comments, make sure you put them, or questions, put them in the comments below, and thank you for watching.